Welcome back to Section 2 of the Scrape the Planet course. I'm your instructor, Mitchell Edwards. If you didn't watch Section 1, that gave you kind of an intro to who I am, what this course is going to be all about, and we're now towards the tail end of Section 2. I highly recommend going back and watching the last couple of videos in this section. So now we are in the last video of Section 2. We're going to be talking a little bit more about scraper design concepts, and we're going to be getting even closer to the code. Next section is going to be the section where we actually get our hands dirty with code, but we are actually going to open an IDE for this one, so it's not going to be just 100% whiteboard like it has been. So let's talk about design. A scraper is only as good as the brains that you code into it. A dumb scraper that's badly designed will give you bad data or none at all, and it will do it very inefficiently. You have to build scrapers with actionability in mind. Don't gather useless data and gather it in an efficient manner, and you'll have a much better time during the development, deployment, and maintenance phases of this whole project. A lot of these design decisions are specific to the target site, so we'll get a little bit more into those decisions once we get to the practical portion of the course. But there's a general design approach that's high level enough to describe without a specific application, and useful enough to describe now rather than later when we have a specific application. I like to break a lot of these programs down into verbs, nouns, and adjectives. Verbs, nouns, adjectives. I'm just surprised I spelled that right. So, verbs, nouns, and adjectives. This is something that I learned when I studied object-oriented design concepts, and this kind of OOP philosophy has its own issues that a lot of people have talked about in the development space that are much smarter than I am, so I'm not going to go into that as much. But this particular part of the design concept is kind of stuck with me. Here's how I think of it. We're going to continue using a general description of a social media scraper since they kind of illustrate these design concepts super well. Each data point, such as a user or a post, are nouns. So let's start charting this stuff out. So we've got users, let's say user profile, and posts. So each data point, such as a user or a post, are nouns. Each noun has a descriptive adjective, such as follower account for users or likes for posts. So let's write that down. Follower count and likes. So a user profile is going to have a follower account. So we're going to draw an arrow there. There's a relationship, and each post is going to have a like. Each noun has relationships to other nouns. A post may be a reply to another post, and each user follows another user. So you have two different kinds of circular relationships. Each user profile is also going to have posts. So all of these different things are going to kind of tie together into themselves. I generally tend to create at least a general framework in my scrapers around these nouns, adjectives, and relationships. If I'm gathering information on users, I create a list of all of the adjectives I might want to gather from those users. So we've got follower count, we've got likes, we've got date created, and that might be an adjective both for a user profile and for a post. Obviously, they're going to mean different things. So this is where your previous planning process immediately adds value. If you fleshed out your database, your nouns and adjectives are already in place in the form of a database schema. So you already know exactly which objects that you're going to want to scrape and all of the associated adjectives to those. So it's a lot easier if you've already done that in your database schema. So once you have that list of nouns and adjectives you want to gather, you consult your planning documents to determine what API endpoints you need to visit to gather those nouns and adjectives. This is where you start building out your verbs. Verbs are the actions your scraper will take in order to gather those nouns and adjectives. Verbs, at least for me, usually take the form of individual functions in your scraper or your spider, but they don't necessarily map out like one-to-one. I may have a function that gathers all of the information I want from a user in one call to an API endpoint. So for API, we're going to hit /user. And that is going to be related to this noun. In that case, you don't really need to break out a different... In that case, you don't really need to break out a different function for each adjective to describe a user. You don't need a /user follower count or a /user date created. You just need the one /user call. However, if, for example, there's a separate API endpoint for just the follower account, so API follower count, I'm just gonna do follow count because I'm lazy, then that is going to be what only gets, I'm gonna have to draw a weird arrow here, it's only going to get that follow count. So you're going to be missing a lot of information there, and that's just going to be a different way that you have to interact with the data. And in that case, I would develop one function, one separate function to hit that API endpoint, generally speaking. If there's like a separate API endpoint for the follower count, following count, and the user creation date, I can create multiple functions, which I would write down as verbs to gather all of that information and create a complete picture of the user, which is a noun, made up of associated data to describe the user, which would be the adjectives. I usually document all of this in the form of skeleton code. Skeleton code is a general layout of what will become the body of my scraper. I don't start scraping the data right away. I just describe the methodology of scraping that data in the form of data schemas, functions, and classes sometimes. I don't use object-oriented programming as often, but I still do occasionally. This will make more sense once we dive into the practical part of the course, but building proper skeleton code can majorly speed up the initial stages of scraper development. Each function is a verb that gathers adjectives to describe the nouns that I want to store. There are also verbs or functions that will handle the communications with my storage infrastructure, so something that will actually set up the connection to my database and tear it down whenever my scraper exits, something that will actually handle the transactions that I will use to actually store data with the database, things like that. By the end of this phase, I'll have written an outline of what data my scraper will gather, the nouns, what information about that data will be gathered, the adjectives, and what functions will handle the scraping and storage of that data, verbs. The skeleton code will just need the guts or the implementation of those verbs to actually be a functional, well-designed scraper. Now for the moment you've all been waiting for, actual code. Kind of. I'm going to give an example using a made-up API to show you how I'd approach creating skeleton code for that API using the Python language. For the first little bit of flame bait, I use VS Code. It's by far my favorite IDE. I do everything from take notes to develop websites to writing scrapers, especially using VS Code. So we're going to be using VS Code, at least in my part of this. You can use whatever IDE you would like. Let's go ahead and create a new file. We're going to call it section2.py. Let's call it section2_5. I think it's the fifth. Yeah, it's the fifth one, right? Okay. This API is for a social media site called Bubbler. Something like that. The API has, we're going to take a little bit of just rough API documentation here. API has a /user endpoint that will give general information about the user, a /followers endpoint that will give you information about who follows that user, a /post endpoint that will give you a list of recent posts by that user, and a /creation date endpoints that will give you the data that a user's profile was actually created. For the sake of example, let's just say we want all of this. Let's also kind of like give you a peek behind the curtain. This is like how a really badly designed API would look like. You wouldn't have all of these disparate, different like API endpoints just to gather information about a user. It's ugly. First, before we scrape anything, we have a verb to start it all up. We'll want to initialize a connection to the database so that we can actually store the data. So we're going to define a function called initDB. We're going to give a to-do comment, implement, and that's usually kind of like a similar note that I'll leave. And we're going to leave in the comments above it, this is the function that I will use to initialize a connection to our database. All right, so we've got the actual initialization function that's going to handle the connection to the database. Now we're going to enumerate our nouns. So I'm going to create a noun section here. In general, we want to scrape and store information about users and posts. Now, in general, I'll usually use my whiteboard for this stage, or I'll kind of like draw it out on this drawing tablet, but instead of like switching the camera around to show you like my messy office, or switching back and forth on this this drawing tablet, I'm just going to kind of write all of this down in the IDE. But in general, I would kind of take a little bit like more natural notes, whatever's natural to you, whether you've got like a notebook or something like that. I would kind of write a lot of the nouns and the API documentation and stuff like that off to the side somewhere. So we've got our two nouns. We've got our users and our posts. Now we want a list of adjectives that actually describe those nouns. Each user will have a follower account, a link to their account, and a creation date. So we're going to go ahead and take these notes under here. So they're going to have a follower account, account link, and a creation date. Easy. For the sake of simplicity, we're going to consider relationships between nouns as adjectives, just to kind of like, I don't know, make things a little bit easier when like explaining the skeleton coding process. A post will have a relationship with the user since a user wrote each post, and each user will have a relationship with other users in the form of followers. We're going to store these lists as adjectives. So each user will have a follower list, and each post will have a poster adjective. Each post will also have a date, pretty easy. Let's just call it creation date, so it'll be similar to the user, and a number of likes. Number of likes. That's going to just kind of describe how many likes the post got. We're just going to limit it to that. A normal social media site will have like tons more adjectives that we could add in, but we're just going to say that those are the ones that we're interested in. Now we're going to move on to the verbs. Let's say we've already got a list of users that we want to scrape. So since we're starting with the usernames of that user, that's going to kind of make things a little bit easier. We're not going to have to develop a spider, for example, to gather things dynamically. We already know which users that we want to scrape. We're going to iterate through that list of users and act on that list first. Maybe later on down the line, we'll kind of develop some more complex stuff in there to discover new users. So let's go ahead and define ingest list. And that is going to take in a CSV full of usernames. Sudo implement return. Alright, so no, this one's going to have a file name that we'll want to grab, and our DB will have a database name. We're just going to keep it a database. And it's going to have a user, and it's going to have a password. All right, so basically what I'm doing here is I'm passing in all of the variables that I'll know that these functions are going to use. It doesn't save you tons of time, but it kind of helps like organize your head and have that already put together. So this CSV is going to pull in everything, and we're just going to create dummy variables that don't actually have anything. So for example, users, and then we're going to loop through those users after we gather them. So let's go ahead and say load users with values and file. First, we're going to have to initialize file and pull in usernames. Then we're going to load the users variable from the value with the values in the file. Then for user and users, so we're actually writing code here, but it's not going to actually do anything for right now. So for each user, what are we going to do? So we're going to create basically what is going to end up being a define gather user top level function. And all it's going to take is a username going into it. So we've got our username. We're going to go ahead and gather the information that we want based on the adjectives and the nouns that we have above. We're going to hit the /user endpoint for basic info. And that's going to just gather the very basics that we'll need. Then we're going to need, then we're going to need the user link. So that basic info is going to have things like the user link, for example. That's going to be one of the things that we gather from our non-existent API. Then it's going to pass the username to a function that will get the follower account for that user. So follow count equals followers with this username. And we're going to create that function up here above. Def followers username equals that. Sudo implement. And we'll just create a dummy variable for follow counts. Load it up with 0. Return follower count. So now we've got our follower account. So we're going to hit the followers endpoint to get the number of followers that a user has and return that data to the top level gather user function, just like we did right here. And let's just say that with this API endpoint, it's going to return our follower count, and it's also going to return a list, follower list. There's probably an easier way to do this, but we're creating basically the worst API possible in our imagination right now, and we're just going to keep making it worse. All right, so we're storing the follower count and the follower list here. We're gathering all of this information about each individual follower, and basically we're going to do the exact same thing for posts. Def gather posts. I don't know what I'm doing there. And we're also going to take post links equals that. And we're going to do essentially the exact same thing here. So I'm not going to fill all of this out, but as you can see, we've really started constructing a lot of information here based on the schema and our understanding of the schema of the API. And later on, once we actually start implementing all of this stuff, we have these bones, this framework already put in place, so we don't have to kind of make those design decisions as we're trying to implement them as well. It's much, much, much easier to make those design decisions up front instead of doing it later on when you're really focused on 1,000 different things. It also kind of helps a lot whenever you're working with the team. You already have your skeleton code written out, so the whole team is going to be on the same exact page as to how all of those different functions are going to work together. So now that we have skeleton code that describes all of the data that we plan on gathering alongside functions that will handle gathering that data, truthfully, the next part is super easy. The implementation itself, especially for an API scraper like we've been talking about before, is very simple. We'll move on pretty quickly to the next section now, where we'll actually discuss the practical application in a real-world scenario and start writing some real-world code. This was a kind of shaky example of how I would do a theoretical skeleton code like beginning project, but we're going to actually apply that kind of like methodology in the next section to a real life application. You're going to be developing your first scraper very, very soon. Thank you so much for sticking around for section 2. I know it hasn't been as sexy. We haven't been writing a ton of really interesting code. Even the code that we did write doesn't actually do anything. And I know it's been a lot of whiteboarding, and I know that that's boring, and I know it's just kind of me talking to a screen for a while. The next section is going to be a lot more fun. We're really going to dive into the practical part of it, but I want you to remember all of the things that we learned in this section. If you feel like you have to, go back and rewatch some of these videos, or at least watch like the high-level points to understand the design methodology and the design decisions that we're going to make in the next sections. I'm going to follow essentially the same methodology throughout the rest of the course. And if you kind of picked up that methodology early in this section, it's really going to benefit you later on. If you've enjoyed this course so far, please let me know in the reviews. You can wait until the end of the course if you would like to leave a review. Just let me know what I was doing right. Let me know what I was doing wrong. I really am planning on kind of updating this stuff and changing some things around if enough people say that, you know, there's some changes that they'd like to see made. If you're watching this on YouTube, obviously that will take the form of likes, comments, shares, you know, discussions on social media, all of that fun stuff. So please let me know if there's anything that you would change, if there's anything that I did wrong, if this course just straight up sucks, totally get it. Just let me know. Feedback always helps, and if it's positive feedback, it especially helps because it kind of spreads the word and allows more people to find the course. Thank you so much, and I'm looking forward to section 3.